It turns out there's a more useful, less tedious form that can help you out in those cases where you're essentially far away from the y-axis. And that's the point slope form of a line. Let's say we have our fancy function again. Here's our fancy function. And we want to, that is not how you spell fancy. There's a y in there. You want to linearize it around this point. So I'm going to zoom in and it looks like a line. Fantastic. And the point that I'm zoomed in on is, let's say, x1 comma y1. Really, this could be something like -2, 5, where -2 is x1 and 5 is y1. But I'm going to talk generally like x1, y1. Okay, and we can look at this point. We know exactly what this point is because we're zooming in on that point. We can still find the slope of this line pretty easily. It's just rise over run, no big deal. Though there's my slope there. And the point slope form of the line is in this format. Y minus y1 equals m times x minus x1. Fantastic. I don't have to do any extrapolating to figure out pieces that are outside my vision here. I have my point right away, x1 and y1, bam, and I can find my slope right away, rise over run, bam. So this is actually a much more efficient and I would say convenient form of a line. It looks a little bit messier. You have some more components than just our y equals mx plus b. It represents the same thing, and I don't have to do any extrapolating to find b. So I suggest that this point slope form of a line is more handy for what we're about to do.